Hi y'all, welcome back. I'm Pi, and today we're going to be taking a look at problem number 12 from the 2015 AMC 10B. For how many integers x is the point x comma negative x inside or on the circle of radius 10 centered here at 5, 5? So I see the word circle and I think I'm going to draw a circle. And this is the center, 5, 5. And about 10 down is the radius, 10 to the side is the radius. So my coordinate axes are going to intercept it, something like this. And here I go. It's not a beautiful circle, but it is one. One way I can approach this problem is by saying, I'm going to find all the points that satisfy x comma negative x within this circle. I mean, that looks like a 1 comma negative 1, maybe a 2. No, wait, 1 comma negative 1 is going to be 1 over, negative 1 down. 2 comma negative 2, like, I don't know, does that fall inside? Is that outside? Well, there's actually a more mathematical and intuitive way to do this than to just guess and check for points. And that's taking a look at the equation of a circle, which is going to be x minus k, the whole squared, plus y minus h, the whole squared, equals r squared. And this equation is for a circle, especially one that's not centered at the origin. Now, this is given a center KH, which I know is going to actually be 5, 5. And I know that my y over here is really going to be negative x, because remember, I have that coordinate from earlier. Now, there's one more thing going on with our equation that I want to address, and that's the fact that we're going to treat this as an inequality. That's because I'm looking for all these x coordinates that fall in here and on the edge right over here. So instead of finding points that are equal to, I'm going to say they're going to be less than or equal to, which means they're within the scope of this circle. Now I'm going to start plugging values in and evaluating right over here. So I'm going to say x minus 5 the whole squared plus negative x minus 5 the whole squared is less than or equal to 10 squared. Then I'm just expanding. And I see that this is going to be x squared plus 10x plus 25, which is less than or equal to 10 squared. Now I'll be grouping like terms, just doing some algebra here. Canceling those out. Plus 50. And I'm going to subtract 50 from both sides. Divide by 2 on both sides. And get x squared is less than or equal to 25. Now, I have to take into account that I'm looking at both positive and negative roots because I'm looking at the shape over here, which goes to the positive and negative x-axes and positive and negative y-axes. So I can't just restrict myself to the positive root, which I would have automatically said was 5. So I'm going to say x is going to be less than or equal to 5. And x is going to be greater than or equal to negative 5. And remember, if this were just an equation, I would have said something like x equals 25. So I just said x equals plus or minus 5. But now I really want to take into consideration that little fact that when I'm taking the negative root, I'm actually going to be flipping the sign. So this tells us something. This tells us that this point x is within that range, negative 5 to 5. And I'm looking for the number of integers, x. So if I just count that out real quick, I see that it goes from negative 5 to negative 1. And there we go, I've got 5 integers. And then 1 to 5, I've got 5 more. But I'm also taking into account that 0. So really, if I count from negative 5 to 5, I have 11 integers for which this condition holds true. And there we have it. Our answer is option A, or 11. Thank you for watching.